Module 9 error bars. So in this module we will see an overview of various kinds of error bars that we normally use that in charts as well as in the tables. So error bar, what are these error bar? That's nothing but it plots the margin of error in the graphs. So they also represent the errors of ranges or uncertainties in the data. So the two kinds of error bar is that one that represent the scatter or the variability of the individual elements of your data set, while the other one will let you know the precision of how you have determined any of these statistics. For example, mean, what is the error of the mean determination. So these two are entirely different approaches, so you can never substitute one for the other one. So there are various types of error bars, either plotting styles or the method used to calculate the error bar. So we will see one by one. First is the error bar, the various plotting styles. So as you can see here, the plotting style is that, so the error bar will have both caps, but sometimes it is having only one cap. So there is no cap or with cap, or it is only in one direction or both the directions. So that is why the different kinds of plotting style. This is just a personal choice anyone can go for, but most of these graphs in biomedical sciences are usually it is actually the plunger, the dynamite plunger plot, which I already explained to you. It is like only in one direction the error bar goes in. So virtually you can use any kinds of plotting style of these error bars. So more importantly, error bars, there are several methods for calculating the error bar. So those are not by the personal preference, but these are done according to the level of measurement and what is actually conveyed. What would you like to portray, and is it actually a non-parametric or parametric. So if it is depends upon the distribution, then it is you have to go with the parametric, while it does not depend upon the distribution, those methods are non-parametric methods. So most commonly used types of the parametric methods are standard deviation or ST, standard error of the mean, that is SEM, and 95% the confidence interval. So 95% confidence interval is also a parametric approach. While less commonly used types, which are all non-parametric methods, are the median and the range, median and the quartiles, and median absolute deviation, which we already discussed how to calculate the median absolute deviations. Most of these statistics we have already discussed, that it's something like a recap of the everything. First is sample standard deviation. So it is nothing, the standard deviation is nothing but the square root of the sample variance is sample standard deviation. So standard deviation plots the scatter or the variability of the data set. And standard deviation gets slightly higher as n gets higher. So it is very slight, so you cannot take it as a rule of the thumb. So we have already discussed that in the 8th module in 2nd section. So you may wish to go back and check it out how it is calculated. So it is nothing but the square root of the variance, the standard deviation. Now coming next is standard error of the mean or SEM. It quantifies how precisely you have determined the true mean of the population. So it takes into the account of the both value of the standard deviation and the sample size. So both make sense for the standard error of the mean, because SEM is calculated as standard deviation divided by root n. So that is the way to calculate the standard error of the mean. So if the SEM is presented, but you want to know the standard deviation, multiply the SEM with the square root of the n. So simply multiplication of these two values, you are going to get the SEM. So SEM by definition is always smaller than the standard deviation. So standard error of the mean gets smaller as the n gets higher. So that is why this is extremely important, the measure. So I have already explained that in the 8th module of this MOOC. Coming next is 95% confidence interval of the mean. So it tells you how precisely you have determined the sample mean in comparison with the true population mean. So that precision is what is being captured in the 95% CI. So as you can see in this diagram, so as you increase the sample size, so if you have a lot of data, then the confidence interval gradually gets reduced. So if you have a giant data set of millions of sample, then confidence interval is going to be very low. So naturally the confidence of the data is much higher if you have a large data set. So 95% CI is usually represented as plus or minus standard error, plus or minus the sample mean. So, mean plus 95% CI and mean minus 95% CI, which is identical to the standard deviation how it is being portrayed. So, roughly 95% CI is twice that of SEM. So, the more formal way to calculate it is that standard error of the mean multiplied with a t constant. So, t distribution, t star is a constant from the t distribution. So, studentized t distribution is a kind of a probability distribution that we will study more in depth in one of the later module. So, that constant depends upon the degrees of the freedom and the level of confidence you would like. So, for example, 95% is the confidence level that you are looking for and the degree of freedom is 24, then you have to pick the constant from the t distribution table from just these two numbers. So, that is what the t is all about. So, you can approximate it as 1.96 in very large data set, or you can approximate as just twice. So, that is another way out for this 95% CI. So, which one to go for? Is it standard deviation or standard error of the mean or the 95% CI? So, in most of the cases standard deviation is preferred. So, because the standard deviation is what that actually portray the scatter of the data set. So, for the scatter definitely go with the standard deviation. So, SEM, that is standard error of the mean, does not convey much information. Instead of SEM, so if the precision of the determining the sample mean is what you would like to portray, then go with 95% CI, because the normal SEM is only 68% is the confidence, which is rather very low. So, you can increase the confidence in it by going with the 95% CI, which is a rigorous method to portray your confidence in determining your sample mean. So, to compare the means of two or more groups, so definitely the best option is 95% CI and see that does it overlap or they do not overlap. If the 95% CI do not overlap, that means that it is significant, but if the SEM do not overlap or do overlap, it does not mean anything. So, if the SEM actually overlaps, then that means that it is insignificant, that means the p value is higher than the threshold p value. So, if you want to create a persuasive propaganda, that is actually it is a quote from one of the nice book. The book is known as The Naked Statistics. I suggest all of you to have a look at that. It is a very accessible form, the statistics for the commoner, by the Charles Whelan. It is a very nice book, The Naked Statistics. So, a quote from it is that if you want to create a persuasive propaganda, what is that? So, if your goal is to emphasize small and unimportant differences in your data, show the error bars in standard error of the mean and hope that your readers will think that these values are standard deviation, because the standard error of the mean is always less than standard deviation. So, to convey that this is a really nice data you present in SEM, and then let the readers think that these are actually standard deviation, and you do not write anything on the figure legend. As you see, it is cheating and it is a serious academic malpractice. You should never do this mistake. So, it is just a pun that this statement has been quoted. So, if your goal is to cover up the large differences, then show the error bars as standard deviation and then hope that your readers will think that they are the standard errors. So, definitely both of these scenarios are cheating. So, never go with that, because this is a serious academic malpractice. It is actually scientific misconduct, but it is commonly practiced across the sciences, which is highly unfortunate scenario. So, non-parametric error bars are also there. So, some of the commonly used non-parametric error bars are median and the range. So, the median is presented and plus minus the range. So, range, as you know, it is maximum and the minimum. So, median and the quartile is another way out. So, it is actually at 75th percentile and bottom will be at 25th percentile. So, median and the quartile you can use it. Median and median absolute deviation. So, it is a median absolute deviation is just one number, as I told you. So, it actually equidistant from the median in a column chart. You can do that as well. So, these methods are preferred for the non-Gaussian distribution. So, if your distribution is non-Gaussian, if you are sure that the distribution is not normal, or if you did a K2 normality test and then you see that it is actually not normal, then go with any of these 3 methods or other methods which are non-parametric. So, you can see that in this the graph, you can see that various error bars for the same data set, you can see that you can compare across that one. So, the choice depends upon the level of the measurement and what is conveyed to the audience, you know, and also is it parametric or non-parametric. So, all these are important thing. So, what if the 2 error bars overlap? What can you make out of it? For example, if it is a standard deviation, you have 5 groups and you have calculated the mean and you also calculated the standard deviation. So, the standard deviations actually you know, overlapping between the groups. So, does that mean that the groups mean are not significant or the group means are significant? So, the easiest answer is that you can never make anything if you compare the standard deviations. So, if it overlaps or not overlap, it is immaterial. Now, if you instead of SD, if you have plotted SEM, that is standard error of the mean, if 2 are not overlapping, remember standard deviation is larger than standard error of the mean, SEM is always shorter. So, it is very easy to get you know, 2 SEMs are not overlapping, it is extremely easy. If it is not overlapping, what will happen? Can you call it as you know, the differences in the means between the groups are significant or not? No, you cannot, because SEMs is a very poor measure of comparison between the groups. So, much better option is 95% CI. So, if the SEM do overlap, can you make any guess about it? Yes, you can make it. So, it means that the group means are not significant. You know, so you can say that the p value must be higher than 0.05, that the threshold alpha that we are going to discuss in the p values. So, that is what the SEM. So, if the SEMs are overlapping, that means that it is not significant at all, but if the SEMs are not overlapping, you can never say that it is significant. Now, coming to the third one, that is 95% CI. If the group 95%, as I told you, SEM, it is almost twice of the SEM is the 95% CI. So, it is quite wide. So, if the 2 groups SC, you know, that the 95% CI overlap, what does that mean? It means again nothing. You know, 95% CI usually it overlaps. Now, if the 95% CI do not overlap, you see that it is actually width of the 95% CI is usually wide and still it does not overlap. That means that difference has to be really significant. Yes, 95% CI, if it is not overlapping, that means that, you know, the differences in the group means are significant. So, these are some of the valid conclusions you can make it out. While beware, there are so many common mistakes that the students do. Some of these mistakes are explained here. One is that the plotting error bars without stating in the figure legend how it was determined. For example, you plot the SEM and do not say what the error bars mean. So, then you might actually give it to the readers. So, readers might think these are not SEM, but these are SD. This is truly a wrong practice. You should never do that one. So, plotting the standard deviation or standard error of mean error bars for the samples that are non-Gaussian. Remember, SD and SEMs are applicable only for the normal distribution. So, if it is not a normal distribution, going with this SD and SEM makes no sense. Choosing SEM instead of standard deviation to plot the scatter. So, again, if you want to plot the scatter, you have to go with standard deviation, not with SEM. So, SEM is entirely different concept. Plotting mean and error bar instead of other far more effective data visualization tools, something like histograms you can go, or box and whisker plot, or the column scatter graph. So, instead of that, you simply constrict all your data summary into just one number, that is mean plus or minus standard deviation. That is not the right way. So, in summary, the error bars plot the margin of the error, that is the precision or the scatter. So, it could be precision or the scatter in the data set. So, graphs should ideally have the error bars for a better data visualization. So, if you are presenting some bar graph or scatter plot without error bar or with error bar. So, with error bars is definitely have advantage over the without error bar. So, make sure to plot the error in your diagrams. Broadly, there are three types of error bars. So, standard deviation error bars, so standard error of the mean or 95% CI. So, decision of the type of error bar to be used to summarize the data depends on the information to be conveyed rather than merely a personal preference. So, as usually the information to be conveyed is a scatter or variability. In most cases, standard deviation is preferred over the other types. SEM does not convey much meaningful information instead of SEM, that is standard error of the mean. So, if the precision of determining the sample mean is to be conveyed, 95% CI is preferred and its advantageous. To compare the means of two or more than two groups, it is always better go with 95% CI. An ulterior motive of choosing standard error of the mean error bars over standard deviation error bar is to reduce the width to emphasize non-existing spurious differences. As explained previously, this is a form of cheating, a serious academic offense. For non-Gaussian data sets, median width range or median width quartiles are more appropriate, as both of these representations are non-parametric. So, please remember to watch a screencast of the charting and adding the error bars and all as part of the GraphPad Prism training appended in this course website. So, please look that one as well. So, how to add different error bars as well as how to create the charts using GraphPad Prism software. Hope you liked it. See you again in the next session.